It's Dr. Ron England again, and we're going to be talking about good old questions that go with module number 7. And now we're actually starting to compare things, comparing projects with each other. If you might have been paying attention, you might have noticed that the calculations are all pretty much the same. We've really only got one equation that deals with future versus present worth versus annualized, because, well, it can all be done in one equation. Now, what we're going to be doing is we're going to be using that. Now, we do have another equation because we do actually have to deal with the concept of compounding and effective interest rates when situations with the interest rate, and that's just a man-made thing, that good old interest rate problem. So, but we now understand the annual, and we understand the concept of compounding, right? Right. But you're still 1 plus I to the n is the equation that rules. Now, let's look at how we can compare projects. And you're going to find that when we do comparison of projects, we're using all exactly the same concepts of time value of money with different ways of comparing them. And yes, there are a bunch of different ways to compare projects, because I call it solving for P, solving for F, solving for A, and solving for I. Yeah, those, and actually there's another one, solving for N. You can even do that too. We're not going to really do a whole lot of that one. Solving for N is determining what is the break-even point of different projects. Like this project here could have that. So let's look at this first one. 2 alternatives for a traffic light in an excluded area. Basically, it means you need to figure out how to power that light. So you got a potential of doing installation of solar power, or you got the installation of just doing it by running the good old electrical lines. So, different initial costs, different operating costs. Notice in this case that you have, with electrical, you have low installation, high annual operating. With solar, you have high installation, low annual operating. Okay, that actually tells you that at some point you're going to actually be able to break even there. But really, how do you do the comparison of these projects? What we're going to do is just compare the costs. Take everything and bring it to present worth. So you got an annual cost that you bring to present worth. It gives you a total cost of, in this case, $5,911.71 with the numbers given. And you have the solar powered, which has the higher initial cost and the annual cost. And notice in this case that the total cost of the electrical powered is lower than the total cost of the solar. Now, let me kind of go over one of the other concepts that goes with this, because you notice in this situation, the electrical is less expensive than the powered when you bring everything to present worth. What if I changed N to 6? What if I changed N to 10? Change it to 10. Now notice that the cost of the electrical powered exceeds the cost of the solar powered. Notice that I actually have this entire thing live. All those numbers are live numbers because that's the way I write the calculations. If you notice, if you look up here at the top, every single one of these guys, except the ones that are given numbers, are simply equations. All right. Good to know. And by the way, could I have done this by just saying, hey, let's take each individual value and put it into present worth terms and sum them up. Exactly what I did here. Notice that the initial costs, there is no conversion because, well, that cost is the present cost. And each of those individual payments can then be brought into present worth, and you add those together. Oh, look at that. Again, it comes out to be the same number. Well, it should give you a level of confidence if you do it both ways. All right, same thing here, same concept, same type of problem. The only thing that we've got to do right now is we're actually dealing with a salvage value. So you have an option A, initial cost, operating cost, salvage. B, initial cost, operating cost, salvage. Well, you can do the same exact thing here. It's exactly the same equation. In fact, I just copied. You notice my spreadsheet looks awful familiar. You know why? Because I just copied it to a new tab and I just changed the numbers. That's all I had to do, except that I had to add a few more rows. Why did I have to add a few more rows? Because I have a salvage, and I have to convert that salvage to a present worth of the salvage. So the salvage in one case was 5,000, converting to a present worth of a salvage. 1 plus I, okay, well, I'm going to give you the equation. 1 plus I to the n. Same thing over here. By the way, same number in both situations. P over F, present over future. Okay, same thing. Also, by the way, the P over A is the same thing, that A in your class. Now, notice in this case, I did leave the numbers as negative numbers, because in this case I had positive and negative values. The salvage was a positive. It's money you got back. Everything else was a cost. So you can now look and say, hey, which one cost you more or lost you less? Okay, but if you go to the present worth, this is actually a better present worth than this one here because it's not as negative. And just to show that you can do it, just using the 1 plus I to the n, okay, there you go, those values with the salvage built in there also. So just basically all the values at the times that they were actually done. Same thing, straightforward. And if you look at all these equations, you'll notice it's, oh my gosh, it's divided by 1 plus I to the n. Not so bad. All right, capitalized equivalent cost of a dam that will cost $25 million now and will require $2 million in maintenance annually. Okay, so what's really happening here is n is going to, well, essentially infinity here, but you know what? There's an equation for that. Okay. It's, whoops, let me see if I can put me right there. There it is. Whoops, CE B2, the interest, B2, the number, manualized cost divided by the interest rate. Now, suppose you can't remember that. Okay, and then what you do is you take that capital equivalent cost and you add in the initial, and voila, you've got the total cost. What if you can't remember that? Well, you could calculate the present value and just keep jacking up n. Let me show you, for example here. If we were to change this n to its 5, let's say we changed it to 500. Okay, now suppose I changed it to 501. Oh, look, the costs didn't change. Okay, maybe if I change it to 1,000. Notice those total present worths didn't change. The reason you see pound signs there is because that number got really, really big. And I'm going to bring it back over because I don't need that. But that total present worth value didn't change. Well, that's because it levels off from that annualized. So anyway, what does it level off to? Well, strangely enough, it levels off to the total annual cost divided by the interest rate. And that's a pretty simple problem. You really kind of like those when you run into those, but just remember that's the asymptote for these guys. They level off at that as n gets really large. So in the situation where you'd say, oh, they didn't give us n, okay, but it's a project that's going to last a really long time. We typically expect dams and roads and things like that to last a long time. Oh, here's a fun one. How many dollars would be required today to purchase an item that increased in cost by exactly the inflation rate if the cost 30 years ago was 1,000 and inflation rate was 4% per year? And that's kind of just your basic 1 plus I to the n. We just are saying that the n in this case is the inflation rate. Okay. Just a way of wording it that was different. Okay. But the required today should have given it away. This is the present worth of something. And the only n we got is 30. Now, we can go a little bit further with this because we actually do have the ability to deal with inflation and interest as two different things. Okay, the concept of constant value dollars. Well, you know, dollars aren't constant value. They just aren't. However, if your dollar amount changes at exactly the same rate as inflation changes, it actually is a constant value dollar. If your dollar just kind of like, as inflation goes, it goes up like that. Okay, right, you know, when this recording is being made right now, we are dealing with inflation rates that are, you know, a little bit higher than what we've experienced in most people's recent memory. However, being an old man with a white beard, I remember the days of Gerald Ford and whip inflation now and interest rates that actually topped over double what they are today. Yes, twice as much. Look up good old slogan, whip inflation now. Ba, 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 ba. Underneath the Ford administration, that would be after Carter. Gosh, I would think back when that was. That was that 70s? That was like mid to late 70s. I just brought by my memory. So yes, inflation has gone up, and inflation has gone down, and inflation has gone up again. It does that. Concept of a constant value dollar. So basically, in this case, what we're going to do is we're going to calculate this present worth. I think they're actually present worth of the machine underneath underneath a constant value dollar, which is basically a dollar that changes at the same value as inflation. And it's just the same as calculating the present worth, knowing the future worth, using your rate of inflation. This would never be done over this period of time, by the way, over 6 years. There's really very little chance that inflation rate would stay at 5% and stay there for 6 years. You would actually have to calculate different values of inflation changing per year. Then, if we want to actually adjust the whole thing for the actual interest rate at the same time, we can take this value and then we can convert it again to a present value by, instead of using the inflation rate, we use the interest rate and the inflation rate. Woof. Okay, well, it is what it is. Then current dollars. That's the term. That's another one of the many names for inflation adjusted plus interest adjusted amounts. If you wanted to do it in one step, you'd have to find that effective interest rate that is the inflation and the MARR, the interest rate that you'd be dealing with. You do that, and it's funny because it's not a challenging calculation, but it's one that's hard to remember. It's the two inflation rates added together plus the two inflation rates multiplied by each other, which in this case gives you an effective interest rate of 15.5, which, by the way, if you then multiply by that original 25,000 and work it out, gives you exactly the same number as doing it separately. And by the way, had I done it in a totally different order, had I originally dealt with a 10% interest rate and then inflation adjusted for the extra 5%, I would have gotten the same number. Also coming up with the effective interest rate, I get the same number. All right. Now, some key stuff in this guy here. Constant value dollars. Well, we don't really have constant value dollars, but if you had a concept of a dollar, and remember, a dollar is not necessarily a piece of paper. But suppose you actually have an account that automatically adjusts your money by giving you interest that is completely matched to the inflation rate. Now, this sounds all good and dandy, but here's the thing. We may say the inflation rate is 5% per year. If you've watched my videos, you know that the inflation rate isn't just a single number because different things inflate at different rates. So what we have to do is we have to look at the typical cost of specific items, how much they adjust over time, and come up with this concept of an average of all of these things. And also the fact that inflation isn't even the same in different areas of the same country. So an inflation rate is really a whole lot of stuff put together. Just be happy that we just give you a number and say 5% is what it is. So anyway, I hope you enjoyed this one. I hope you learned a little bit from my calculations and my my little bit of extravagant communicating about these things. And I hope you look forward to the next calculation example and lecture from me. Thank you much. Bye-bye.